Good afternoon, everybody. We're talking about what we can learn from hackers today. And I thought I'd start off with a story about two of my favorite hackers. Anyone know this hacker? Sammy Kamkar. Sammy is most definitely a hacker. His first foray into hacking, or his first public foray into hacking, was back in 2006 when he authored js.spacehero, which is a JavaScript virus, one of the first cross-site scripting worms to be released on the internet. He did it on MySpace. And when he encountered this vulnerability and had this virus, he asked himself, what can I do with it? And he decided the best thing that he could do with a virus on MySpace was to get more friends on MySpace. Didn't have enough friends at the time. And so this cross-site scripting virus he weaponized into a prank that everyone who was infected with it on MySpace would become his friend and then post to his wall saying, most of all, Sammy's my hero. And he wrote up his virus, gave it to one friend, and went to bed very satisfied with himself, looking forward to seeing what was happening in the morning. 7 hours later, it's working. He's got about 221 friend requests from lovely people on MySpace. He refreshes it about an hour later, notices he's got 480 friend requests from the good people on MySpace. And he stops for a second and thinks to himself, something's gone quite wrong. If we fast forward about 10 hours from that, Sammy now has 1 million friends on MySpace. The only person more popular was Tom at the time. Then he notices that MySpace is down. He's local to Los Angeles, where MySpace is built and developed. He knows some people who work at MySpace. Tries to decide whether he should just go over there and apologize and say sorry. He decides to just sit tight for a bit and wait for one of them to contact him so he can apologize. Instead, he gets contacted by the FBI, enters into a plea agreement on a felony charge under the CFAA in 2007. He got 3 years of probation without computer use. Much more generous than the 2-year punishment you had to endure stuff. Also got 720 hours of community service and an undisclosed amount of restitution. We feel pretty good about this. Sammy's clearly a horrible individual for getting so many friends on MySpace. But at the same time, there's another individual who found another cross-site scripting vulnerability in another social networking site. This one was Chris Putnam, and he found it in Facebook. His thought process for what can I do with a cross-site scripting vulnerability in Facebook is maybe I can rewrite all of the CSS on the page to make it look like MySpace. So they created FaceSpace, which everyone on Facebook who got infected with this back in 2006, your profile suddenly looked like a MySpace page instead of a Facebook page. Instead of the FBI reaching out to him, though, the founders at Facebook reached out to him. Dustin Moskovitz, who ran the engineering team at the time, reached out and said, hey man, why don't you cut this out? And by the way, you could come help us fix it if you're into that type of thing. He ended up flying out to San Francisco, applied for a job, ended up joining the engineering team there, worked on a lot of the core fundamental security improvements to the site early on, made my job much easier when I showed up as the first dedicated security person at the organization. And in fact, the presence of Chris Putnam and a number of other individuals like him early on in the Facebook engineering team was what made the culture of the organization even appealing to me in the first place to join. But he also built Facebook Video, was one of the core engineers on Facebook Chat, and all told, has probably added several $1 billion in market cap to Facebook as an organization. Facebook Video is on par with YouTube at this point. Meanwhile, Sammy was busy doing community service every Saturday for 3 years no computer access. But his contributions to everybody else didn't stop there. He got back into hacking once he got his internet access restored, computer access restored. He's done a tremendous amount of research into privacy protections on privacy trackers. If you've used any modern web browser, you are safer thanks to Sammy. He has done research into remote start on automobiles, on garage door openers. Your life is unquestionably better because of Sammy today. And it is a shame that we missed out on 3 years of his genius because of the way one organization reacted when they could have chose to react a very different way. That core trait that both Chris and Sammy shared is something that you'll find in every hacker out there. The one commonality across almost all of them is their incredible curiosity for understanding how technology works, how it can serve us, and how it can fail us. And the main thing that we can learn from hackers when we sit back is how can we leverage this curiosity for good rather than pranks or malice. And if there's one thing that you take away from this, it would be this. Ask yourself, how can we leverage and capture that incredible curiosity that all hackers exhibit and make it a force for good rather than any alternatives? The most common thing that stops us from doing this is this very, very dated security mindset that we must enforce security through obscurity. We can't allow people to be curious about how these systems work because they might learn something that impacts the security of the system. You'll be hard pressed to find a security professional who still invests heavily in security by obscurity, even though it is valuable defense in depth, but you'll routinely see it manifest itself in statements like this. This is Mary Ann Davidson, Oracle's chief security officer, advertising that they don't claim to find every vulnerability. They know there are vulnerabilities in their products. They don't find all of them. But that doesn't justify you as a customer reverse engineering any software that you get from Oracle in order to find vulnerabilities. In fact, if you do so, you're violating your terms of service and you can expect Oracle's legal team to come after you. We're not even talking about hackers here. We're talking about customers. It's software that you paid for, that you purchased, that they acknowledge has vulnerabilities in it, but if you attempt to look for those vulnerabilities, you're in violation of your terms of service. This is a horrible idea. I hope we're all on the same. There's no reason why this should be the default state of the world. The federal government takes a little more open-minded approach in some places where they describe system security as being a state that should not depend on the secrecy of the implementation or its components. This is in the NIST guidelines for how all federal systems should be designed and implemented. But I'm a little partial to how Jeff Massimilla at General Motors describes it. A little more blunt, security through obscurity. It's just a really bad idea. Don't do it. And so what happens when you start setting this aside and you start asking, what can we learn if we bring curiosity to our products, our services, and we stop depending so heavily on its obscurity to generate security, and we just ask people to investigate it? A big part of the service that we provide to our customers is giving them a throttled access to hackers. You don't normally want to do this with thousands of hackers at once, so we help introduce it. And we find that in the first 6 months of organizations who make this shift to let's see what comes up if people look around in our code, we find they start working with about 30 hackers in month 1 and end up with about 70 hackers in month 6. And what they learn from those hackers is unquestionably across the board, if you ask some hackers to look at something and apply their curiosity to the software, they turn up vulnerabilities that everything else before them has been missed. They will, on average, at the end of 6 months, have identified 99 vulnerabilities, 25 of which are critical. And this is a phenomenal example of taking that curiosity that all hackers have and possess and applying it in a way where you learn about vulnerabilities in a constructive, safe manner rather than pretending like they don't exist or pretending that the existing tooling is sufficient to identify all of those vulnerabilities. And the organizations that tend to do this for long enough start to take it beyond just hackers telling them about vulnerabilities, and they incorporate those learnings from those hackers into their software development lifecycle at its very core. The organizations that are engaging with hackers start to realize that the earlier in this process you have hackers engaged and participating, the better off you'll end up being. There's a number of different ways that you can start to measure and quantify this, but one of the most appealing ways to me is financial. So if you are incorporating hackers through bounty programs into your software development lifecycle, it's helpful to stop and ask, what do we learn? What do we learn through that process? We learn that on average, it costs about $100 to get a hacker curious enough to find a low severity vulnerability, and about $1,400 to identify a critical vulnerability. That's just the average organization out there. If you invite a bunch of curious hackers into it, this is largely what it takes to attract them. But if we look up a little bit, when you look at the 80th percentile of these programs, it starts to get quite a bit more expensive to incentivize that same group of hackers to apply their curiosity for good rather than malice. The 95th percentile jumps quite a bit more, and by the time we're at the top 1% of these programs, you start to learn something very meaningful from what these hackers are doing and how it reflects on your development lifecycle. When you look at the average company who asks hackers to help them out routinely finds critical vulnerabilities at $1,400. The top 1% of companies out there find them at $15,000. It tells you a tremendous amount about the state of software vulnerability, or the software development lifecycle, and the scarcity of vulnerabilities in that process. Then if we take this to the extreme and we go one level higher, you've got a category of organization that is doing software development at a level where the amount of incentives that they have to apply in order to find vulnerabilities is astronomical relative to the normal development shop. I put Chromebook on there as an example, but Android, iOS, and a handful of other programs are in this outlier category. And what this tells me is that if you care about endpoint security, you should go buy a Chromebook right now and throw out the Lenovo that comes pre-installed with a backdoor and learn from what hackers and where they've had success in the past. And ask yourself, why doesn't every device that I'm using have a $100,000 bounty on a critical security vulnerability? And the answer is almost none of them have a mature enough software development lifecycle to be resilient against the curiosity of hackers. And that is an incredible learning experience from these programs. I never thought I was going to be doing business with the Department of Defense or the Pentagon, but they took notice of this, and they have also launched a bounty program. What they learned from hackers in a 1-month period was that there were 138 unknown vulnerabilities, previously unknown vulnerabilities. The first one was found in under 13 minutes, and I can't think of a more valuable lesson from hackers. Like, this is absolutely the way you want to learn about vulnerabilities rather than depending upon failed traditional methods. All told, I'll leave you with that most of the top companies today have started working with hackers. They've started trying to ask the questions, what is it going to take to make our development process resilient enough so that we can engage with hackers in a meaningful and productive way? And how do we involve them more closely in the process going forward? And I believe we will all be better off the more hackers are involved in creating for good rather than being left on the outside of it. Thank you.
Thanks, Alex. So your homepage actually has updated those numbers As of now, 31,669 bugs fixed, 3,871 hackers thanked. What are the most common vulnerabilities that they're detecting?
Oh, good question. By far, most of our customers are development companies that are connected to the internet. And vulnerabilities that are exposed or developed through web services are by far the most common by volume, purely because they're the most accessible remotely. But when you look at particular verticals or areas, we have General Motors doing it on cars, and they see entirely different categories of vulnerabilities when they're exposed there. There are other IoT manufacturers. We send internet-connected vacuum cleaners to hackers to identify vulnerabilities, and it comes out with a wildly different range. But they're uniform across what the attack surface is, and hackers unquestionably go for the low-hanging fruit first and improve in volume before moving up to the more complex things. And when you look at the Chromebook example for the top bounties that I'm showing there, they have gotten to a point where the main things that they care about are full takeover of the devices. And that's explicitly what they ask hackers to apply their curiosity towards and come out, hopefully, find less and less of.
So we've heard today so far about the medical device that can be breached, the pacemaker, the autonomous vehicle that could be accessed. What are you most worried about that the mainstream world is not yet taking seriously enough?
I don't think it's any particular vertical. I think the state of software development is in an abysmal state across the board. I think most organizations, whether that's IoT or automotive or finance or medical devices, almost nobody is ready for persistent attacks from a determined adversary. And you can't possibly be in that position until you've taken the mindset to intentionally put yourself in that position. The only organizations that are ready for that today are the ones who have been in that position against increasingly sophisticated adversaries over time. And the vast majority of the cyber attacks and the breaches that we see today are going for the lowest hanging fruit, meaning they're not persistent against individual targets. They move on to the next guy. And so you see these false feedback cycles where you get just a little bit better than everybody else, and your problem seems to have gone away for a while, but it's just because they've gone and applied the same techniques they just did somewhere to all of the other industries or companies in your industry. And then they'll all slowly improve, and then they'll iterate one time and come back to you again. And until we get out of that mindset that we're entirely driven by our investment in security by observing real problems, we're continually going to be catching up across every single space out there.
And lastly, Facebook losing a whole bunch of personal data could be pretty existentially damaging to a company in its early stages. When you were building the protection layer around the Facebook data, what was the hardest part of that job?
Counterintuitively, it wasn't the software development lifecycle looking for vulnerabilities for us. Like we said, if you look at adversaries and attackers, they go for the lowest hanging fruit that's available. And in the case of Facebook, that's usually your friends, meaning all of the data breaches and sustained adversaries that we have weren't attacks against Facebook's infrastructure directly. They were attacks against the users. If I want your information on Facebook, I go after your friends through, and James is going to have far more success social engineering one of them than they are going to have success against Facebook's core data infrastructure. And so the challenges in Facebook's case was there's kind of a baseline of a secure software development that we had to do, that we were continually raising the bar on. But the biggest challenges were all people, all social related.
Thank you for traveling over to share the HackerOne story. Let's thank Alex Rice.